Elementary Science Class 7. Electric current and its effects. Reflection of light. Did you know that one way to change the direction of light is to let it fall on a shiny surface?
Really? I didn't know that. Can you tell me more about it?
Absolutely. For example, a shining stainless steel plate or a shining steel spoon can change the direction of light. Even the surface of water can act like a mirror and change the path of light.
Wow, that's fascinating. I've seen the reflection of trees and buildings in water before. So, any polished or shiny surface can act as a mirror.
Exactly. When light falls on a mirror, it changes the direction of the light. This change of direction by a mirror is called the reflection of light.
I remember doing an activity in class where we got the light of a torch reflected from a mirror. Can you tell me more about that?
Sure, let me explain. In the activity, we covered the glass of a torch with a chart paper that had 3 narrow slits. We then placed a plain mirror strip vertically on a chart paper and directed the beam of light from the torch onto the mirror.
Fascinating. I can see how this activity demonstrates the concept of reflection of light. It's amazing how a mirror can change the direction of light like that.
Absolutely. And we can even observe the images formed in mirrors. For example, if we place a lighted candle in front of a plain mirror, we can see the flame of the candle in the mirror, as if a similar candle is placed behind the mirror. Right or left? Do you know that when you see your image in a plain mirror, it's not exactly like you?
Really? I never noticed that. What's the difference?
Raise your left hand. Now, look at your image in the mirror. Which hand does your image raise?
Wow, my left hand appears as the right hand in the mirror.
Exactly. The right appears left and the left appears right in a mirror image. But it doesn't appear upside down.
That's so interesting. Why does this happen?
It's because the mirror reflects the light, and the image is reversed from left to right. This is a property of plain mirrors.
I see. And what about my name in the mirror? How does it appear?
Try it and see. You'll notice that the text appears reversed in the mirror.
Ah, yes. It's like the word ambulance on emergency vehicles. That's why it's written in reverse, so drivers can read it in their rearview mirrors.
Exactly. And you might have noticed that objects inside mirrors of cars or scooters appear smaller than they actually are.
Yes, I've noticed that. Why is that?
It's because side mirrors are curved, which makes distant objects appear smaller. This helps drivers have a wider field of view and better awareness of their surroundings. Playing with spherical mirrors. Did you know that the shiny surface of a spoon can act as a mirror?
Really? How does that work?
Well, the curved surface of the spoon can actually form an image, just like a regular mirror. If you look at the outer side of the spoon, you'll see your image, but it will be smaller and erect. This is because the outer surface is convex.
Wow, that's so cool. What about the inner side of the spoon?
The inner side of the spoon is concave, and it can form a larger, erect image. But if you move the spoon further away, the image will become inverted.
Inverted? That's amazing. Can we try that?
Absolutely. Let's try it out. You can also use a concave mirror to focus sunlight and even start a fire.
Really? That's so powerful. What else can concave mirrors be used for?
Concave mirrors are used by doctors to examine eyes, ears, nose, and throat, as they can provide an enlarged image. They're also used in the reflectors of torches and car headlights. Images formed by lenses. Lenses are used in many everyday objects, like spectacles, telescopes, and microscopes.
Wow, I didn't know that. Can you tell me more about lenses?
Absolutely. Lenses can be convex, which means they are thicker in the middle than at the edges, or concave, which means they are thinner in the middle than at the edges.
That's so cool. What happens when you put a convex lens in the path of sunlight?
When you place a convex lens in the path of sunlight and put a sheet of paper behind it, you can create a bright spot on the paper. This is because the lens focuses the sunlight to a single point, which can even cause the paper to burn.
Wow, that's amazing. What about a concave lens? Does it do the same thing?
No, a concave lens doesn't create a bright spot on the paper. Instead, it spreads out the light, so you won't see a focused beam.
I see, that's really interesting. Can you tell me more about how lenses form images?
Sure, let's explore that. With a convex lens, you can get a real, inverted image of an object, like a candle flame, on a screen. But you can also get an erect, magnified image, which is how a convex lens is used as a magnifying glass.
Fascinating. And what about concave lenses?
Concave lenses always form a virtual, erect, and smaller image of the object. They are commonly used in eyeglasses to correct vision problems. Sunlight, white or colored? When you look closely, you can see that a rainbow has 7 distinct colors: red, orange, yellow, green, blue, indigo, and violet.
Wow, I didn't know there were that many colors in a rainbow. Why does it appear after the rain?
The rainbow appears when sunlight is reflected and refracted through water droplets in the sky, usually after a rainstorm. This separates the white sunlight into its component colors.
I see. So, does that mean sunlight is actually made up of different colors?
Exactly. When you shine a beam of sunlight through a prism, it splits the white light into those same 7 colors we see in a rainbow.
That's so cool. Can we try that experiment?
Absolutely. We can also try mixing the colors together to make white light, like with a spinning color wheel.